0. Okay, integrating e to the u. Remember, to integrate an e term, it integrates right back to itself if I have the derivative of the u attached here. So if you need to, on this one, do the little integral symbol with the dx, you do it. But I know I need a -1, so then I need a -1 out in front. So that will give me a negative e to the negative x. So if I just look at that, I know I need another -1 here, which puts a -1 here, which is going to now make this positive. Well, I need a negative here, a negative here, so negative e to the negative x. Remember, it integrates back to itself as long as I got the derivative here. So I need a negative, negative here goes positive. You can see this is just alternating. Okay, pattern for integration by parts are the diagonals. 1, 2, 3, 4, 5, and then our horizontal, which we haven't had to integrate yet because it's been 0, positive, negative, positive, negative, positive, negative. All right, I'm going to go down here because I think it's going to be kind of long. So getting this right, I have a negative 2x to the 4th, e to the negative x. Next one will be a negative 8x cubed, e to the negative x. Next, the third one is going to be a negative 24 x squared, e to the negative x. Then negative 48x, e to the negative x. And the last one here, minus 48 e to the negative x. Integral of 0 is 0, plus c. Okay, I think that's a pretty easy pattern. Now we're going to do one where, well, what if this doesn't come to 0? Integral of e to the x cosine 3x dx. Okay, so we've got a u and a dv to define because I've got an x term times another x term that I can't integrate. So at this point, I'm not sure which one to put where. I'm just going to try the e to the x here because I can integrate both of these and I can do the derivative of both of these. So I'm going to start here, and this is the right way. Okay, if I do derivative here, derivative of e to the u is e to the u times the u prime. Well, that's just e to the x times 1. Derivative again, e to the x. Well, I just keep getting e to the x. I can do this all day. I don't know how many of these I need because this is never going to get down to 0. So I'm going to stop here. Come over here, I'm going to integrate. So this is not going to come to 0. So what I want to do is integrate this until I get back to cosine. Once I get a cosine, I'll stop. So I'm going to integrate this. If you need the symbols, put them in. If you don't need them at this point, that's great. Before I can integrate, I need the derivative of the angle attached to the dx. Derivative of the angle is a 3. So I need a 1/3. So I've got 1/3. What has cosine as its derivative is sine. Okay. I'm going to keep going until I get a cosine back, and I should get it back on this one. So again, if you need the symbols, put them in. If you don't, that's great. Derivative of the angle is a 3. So I need another 1/3. Now remember, this is part of, okay, that's why they don't have you do this. I see it. Okay, this 1/3 is part of my integrating down here, so I'm going to put it in parentheses because it's technically not going to be here when I do my diagonal. So now I've got 1/9 And then what has sine as its derivative is a negative cosine 3x. Okay, I'm going to go back and scratch these out so that I don't use those when I do my diagonals, because that was part of the integrating to get me to this next step. So I only have two diagonals. I do have a horizontal that's not equal to 0 this time. Positive, negative, positive integral. Okay, so I'm going to show you, I'm going to start writing, I'm going to start down here because it's going to get kind of long. I'm going to rewrite this and I'll show you why. So we are finding the integral of e to the x cosine 3x. You are going to want to copy this down. Equals, and then we'll do our diagonals. So here, see, I only want the 1/3 sine 3x. I don't want that 1/3 that was a part of this integrating. That's why I scribbled it back out. So I should probably scribble that out too, but not that we use that first one. So I'll have 1/3 e to the x sine 3x minus, oh, no, plus 1/9 e to the x cosine 3x. Then I'll have a minus the integral of e to the x, or excuse me, 1/9 e to the x cosine 3x. Make sure I got that right before I move on. Let's see. Minus. Yep. Okay. Just double checking, make sure I didn't make any mistakes in there. All right. Here I've got this integral that still has the x's multiplied. Oh, and technically I need the dx there, but dx, dx. What I want you to recognize is I've got 1 times the integral of e to the x cosine 3x. Here, I could pull this 1/9 out in front. I've got a minus 1/9 e to the x cosine 3x. Think of them as apples. 1 apple minus 1/9 of an apple. I can bring these two terms together because they're like terms. So what I'm going to do is add this 1/9 integral of e to the x cosine 3x to both sides. I just pulled the 1/9 out in front here. So now this is the same term. They're going to cancel each other out because I got a minus 1/9 and a plus 1/9. Those are going to go away. Plus 1/9 integral of e to the x cosine 3x dx. So what this does for me is it cancels out the integral that's on my answer here. So that's gone. I'm going to add these as like terms. 1 plus 1/9. Well, I'll make that 9/9. 9/9 plus 1/9 is 10/9 times the integral of e to the x cosine 3x dx equals, and I've got these two terms left, 1/3 e to the x sine 3x plus 1/9 e to the x cosine 3x. Okay, well, I didn't want to know what 10/9 of that integral was. I wanted to know what just the integral was. So now I've just got to get rid of the 10/9, and I can do that simply by multiplying by the reciprocal, 9/10. And I got to do that to both sides of the equation. So times 9/10 times 9/10. So that's all gone, and I've got my integral of e to the x cosine 3x equals, just simplifying my fractions here, 3/10 e to the x sine 3x plus 1/10 e to the x cosine 3x and a constant. And there it is. So, if the u doesn't go to 0, integrate until you get the original to reappear. It's usually 3 times here. The third one gets it. And then what happens is your integral will be a like term with the original one. You'll just have a different fraction here. And then you would add or subtract to cancel it out. And whatever you did here, you do to this side. So then all you have to do is combine 1 that you're always going to start with plus the fraction, and then cancel that fraction out by multiplying through by the reciprocal. Okay, so we'll stop here. Your assignment's going to be somewhere. Page 443, Quickie 1 through 6, and then 1 through 10. We are going to be spending 3 more days in this section, I think, at least 2, if not 3, and they'll get a little bit more challenging, but this is just practice the skill today.